Hello everyone. Today we're going to be talking about hydronic heating systems and how they work. Hydronic heating is the type of a heating system that uses hot water to distribute heat throughout the building. This is done through a network of pipes run through the walls and ceiling. In our system, we are having two boilers that are used to heat the water. The hot water from the boilers is then used to heat up clean water for domestic use in the building, which is stored in two heat exchange storage tanks. The hydronic heating system works by circulating hot water through the pipes, which are connected to a series of radiators or baseboard heaters. These radiators are located in each zone of the building. As the hot water circulates through the pipes, it radiates heat, creating a comfortable and consistent temperature throughout the building. One of the advantages of the hydronic heating system is that it can be zoned. This means that each room or area of the building can have its own thermostat, allowing for individual temperature control. This helps to increase energy efficiency and reduce heating costs. Another advantage of a hydronic heating system is that it's quiet and doesn't blow air like a traditional forced air system does. This can be particularly beneficial for individuals with respiratory illnesses or allergies. In this video, I'm going to show you how a manifold works, which is an essential component to a hydronic heating system. The manifold regulates the flow of water through the system, ensuring that each zone receives the appropriate amount of heat.
So here we're having a double boiler, double storage tank, mechanical room we are talking about. Up against the wall, you see the manifold. Manifold is the topic of our video. Manifold is being split down the middle into two parts. Cold on the left and hot on the right. Right here, furthest on the left, we're having two lines coming from the ceiling. Those two black pipes are the returns from zone 1 and zone 2. Far on the right, we have feed for zone 1 and zone 2. You need pumps on the feed. Those pumps gonna engage where zone 1 and zone 2 needs more heat. Going up right here is the supply and return for the water for the heat exchange tanks. On the right, because it's on the hot side, is the supply that is going through a pump and into the tanks. And on the left, on the cold side, is the return from the tanks. This water is giving away its energy inside the tanks to heat the domestic water. This water doesn't mix. Hot water is going into the tanks through a T, and slightly colder water is going to be coming out of the tanks. At the bottom right here, you're having a domestic hot or cold water feed into the tanks, and this is the domestic hot water out of the tanks. Coming down the middle is the supply and the return of water for the actual boilers. On the left side, on the cold side, is the supply, and on the right side is the return. This is the supply for one boiler, supply for another boiler. Return from one boiler, return from another boiler. Supply of cold water is going through a pump into a boiler and is coming out on another side of the manifold. Right here you need a pressure relief valve in case something goes wrong and the system will need to drop extra pressure. You're having another a pressure relief valve right there. The boiler on the right is the master boiler, meaning that this boiler is going to be on most of the time, and the boiler on the left is only going to turn on when there's a demand for it, like on an extra cold day or when a lot of people are using a hot shower at the same time. On the master boiler, On the return of water, you are having an air eliminator. At the bottom of the air eliminator, we're having a T that goes into a pressure reducing valve, also called an oro feed. This is how you feed the system water and how you fill it up. This is a domestic cold water supply that's going into a system. From the back, right there, you're having a line that goes straight into an expansion tank that is collecting excess water when the system expands due to heat. Also, on the return line from the boiler, you're having a fail-safe sensor. This is a water fill sensor. If the sensor gonna see that there's no water in this line, it's gonna shut the boiler off so the boiler doesn't burn out. It's fail-safe. We're having one on the return of the master boiler, and we're having another one on the return of the helper boiler. Pumps require shut-offs on both sides of the pumps, so you can isolate them in case you need to swap them without draining the system. Right there at the bottom, we're having just drain valves if we need to drain the system easily. Basically, this is it. Thank you for watching. Please like and share my video. See you next time.